Yo, 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 yo. Okay, so we are going to look at some grade 8 content. It's been a minute. Grade 8 content, grade 8 content, grade 8 content. It's been a while. Yo, 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 yo. Let's. Yo, 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 yo. Yeah, guys, unfortunately today, no grade 10. We out there, we're just gonna be doing some maths. That's, yeah, I guess you could say in general. Yeah. So let's look at this. Let's look at this. Let's look at this. Let's look at this. Right. So let's come here. Right. We are told that in a grade 8 class there are 18 boys and 15 girls, and the question is write the ratio of boys to girls in the simplest form. Let's look at this again. In a grade 8 class there are 18 boys and 15 girls, right? And the question says write the ratio of boys to girls in the simplest form, right? So here we are looking at ratio. Now guys, ratio, what ratio is? Ratio is the comparison between two quantities, all right? So in this case we have a class, there are 18 boys and 15 girls, so these are two quantities. Now ratio is a comparison of two or more quantities of the same type. So we have 18 boys and 15 girls, and the question is write the ratio of boys is to girls in the simplest form. All right, so we are convinced that the 18 boys and 15 girls, okay, and what they're saying is write the ratio of boys to girls. So that means I need to then set up a ratio of boys is to girls. Okay, now how many boys do I have? I have 18. How many girls do I have? I have 15. And the question says write the ratio of boys to girls in the simplest form. So there's 18 boys and there's 15 girls. How do I write this ratio in simplest form? So the first thing I need to do is I need to find what I call the highest common factor, you know, between 18 and 15. So what is the highest common factor between 18 and 15? The biggest number that goes into 18 and 15 without leaving a remainder. Now guys, there's many ways of actually finding the highest common factor between two numbers, right? So if for instance I write down the factors of 18 and the factors of 15, right? The first factor of 18 is 1, and 1 goes into 18 how many times? 18 times. The next number is 2. 2 goes into 18 how many times? 9. The next number is 3. Does 3 go into 18? Yes. How many times? 6 times. What about 4? No. 5? No. 6? We already have 6. So that's basically all the factors of 18. Okay. Then what are the factors of 15? 1 goes into 15 how many times? 18 times. What's the next number after 15? What about 2? 2 goes into 15? No, it doesn't. So 2 is not going to even be considered. What about 3? 3, yes, 3 goes into 15. How many times? 5 times. What about 4? No. What about 5? Yes, 5 is already there. So that means when it comes to factors of 15, okay, 1 goes into 15, 15 times. 3 goes into 15, 5 times. These are the factors. And what is the highest number that is common for both the factors of 18 and 15? The highest number is 3. So that means that the highest common factor between 18 and 15 is 3. So once I find the highest common factor, it is 3, then I take my ratio and I divide the quantities in my ratio by 3. So 18 divided by 3, what does that give me? 6. And what does 15 divided by 3 give to me? That gives me 5. Okay, so if we go back to the question, it said in a grade 8 class there are 18 boys and 15 girls. Write the ratio of boys is to girls in the simplest form. So what I did is I wrote down 18 boys and 15 girls. Since they want the ratio of boys is to girls, I then wrote the number of boys as 18, the number of girls as 15, wrote the ratio sign is to, okay, the comparison between two quantities. Okay, they are of the same type in that we are talking about the number of boys, the number of girls. They have the same unit. So this is a ratio, and it represents the definition of what a ratio is: the comparison between two quantities of the same type or the same unit. Once I have those written down, I find what I call the highest common factor between 18 and 15, which in this case is 3. I then take that 3, I divide each quantity by the highest common factor. Okay, and that leads me to paradise. 18 divided by 3, 3 goes into 18 how many times? 6 times. 15 divided by 3, 3 goes into 15 how many times? 5 times. So I have a ratio that is simplified, which is 6 is to 5. So have I answered the question? In a grade 8 class there are 18 boys and 15 girls. Write the ratio of boys to girls in the simplest form. Guys, this is the simplest form. Alright, that is the simplest form. Okay, let's look at another question. 4,000 Rand is divided between Emma and Esther. So I'm guessing Emma and Esther have money, but then they want to divide the money between the two of them. But it is well established that 4,000 Rand is divided between Emma and Esther in the ratio 3 is to 5. Calculate the amount Esther will receive. So let us now look at this question. This question has to do with ratio, but it is about dividing a certain quantity in a specific ratio. This one had to do with a ratio but simplifying the ratio. Alright, but this one does not have to do with simplifying the ratios. This question has to do with dividing a particular given quantity, which is an amount of money, between two people in the ratio 3:5. Now, if we look at Emma, it means that Emma will receive 3 parts of the money, whereas Esther will receive 5 parts of the money. So the question is, calculate the amount Esther will receive. Okay. So what is the amount? It's 4,000 rand. It needs to be divided in the ratio 3:5. And by the way, the 3 parts, okay, represents Emma's share. So let's say 4,000 rand is divided between Emma and Esther in the ratio 3. So the first number in the ratio, the first quantity in the ratio, the 3 parts represents Emma being the first, and then Esther. Esther is represented by the 5 parts, okay, being the second party. Calculate the amount Esther will receive. So what do we do here? The first thing we do, guys, okay, which is like the first step, you must add the quantities of your ratio. Add the quantities in the ratio. So the quantities in the ratio is, we have 3. So there's 3 parts or 3 shares of Emma plus the 5 parts or the share of Esther. So we add the ratio quantities together, and what do we get? We get a total of 8 parts. Now this total of 8 parts represents the entire amount, which is 4,000 rand. Let me say that again. This 8 parts represents the entire amount, the total amount. So the total parts, which is 8 parts, represents the full complete amount of 4,000 rand. So what do we then do? We step 2. It would be nice to know how much is represented by 1 part. So what we do is we take the 4,000 rand and we divide it by the total number of parts. Alright, so 4,000 rand divided by 8. Okay, I need my calculator people to tell me what is 4,000 divided by 8. Okay, 4,000 divided by 8. Just for interest, do you guys still remember our long division? You would ask yourself, how many times does 8 go into 4? Doesn't go. Then you would basically extend it and you'd say, how many times does 8 go into 40? Okay. You'd ask, how many times does 8 go into 4? Well, it doesn't go. Then you'd ask, how many times does 8 go into 40? And then just above this 0, you would write 5. Okay. Then what you would do is you would multiply the 5 and the 8. What is 5 times 8? You would write down 40. Okay. Then from there, you would say 40 minus 40, because there would be a subtraction that would have to happen here. Then you would write down 0. Okay. 0. Okay. And then of course, guys, what is happening to my network? Yeah, so that would be 0, 0, 0, 0. So 4,000 divided by 8 is 500, guys. Hopefully we see that. 500 rand? 500 rand. Okay. This is a representation of what 1 part amounts to. 1 part is 500. Okay. But we want to know how much is represented by Esther's amount, which is 5 parts. So what we are going to do, step 3, because specifically we want to know 4,000 rand is divided between Emma and Esther in the ratio 3:5. calculate the amount Esther will receive. We want to know how much Esther will receive. Esther is represented by the 5 parts. Okay, so since we want to know specifically how much does Esther get from the 4,000 rand, we are going to say 5 times the 500. Very good, Ocean. Okay. And how much is that? How many parts? How much money is represented? It's 2,500. That's how much share Esther will get. So that Esther will get 2,500 rand. Okay, and had we been asked how much will Emma get, it means that if we take the remaining amount, okay, which is 1,500, that means that the 3 parts is represented by 1,500. That's how much Emma would get. But we were not asked how much Emma will get. Here in this question, we were asked 4,000 rand is divided between Emma and Esther in the ratio 3:5. Calculate the amount Esther will receive. So we are interested just in the amount that Esther will receive. Okay. So that is a nice ratio question, guys. Nice ratio question. Let's look at the following question. A car driver needs 18 liters of petrol to travel 252 kilometers. A car driver needs how many liters of petrol? 18 liters of petrol to travel how many kilometers? 252 kilometers. The question is, find the rate of his petrol consumption in kilometers per liter. So here we have a typical question that is a rate question. We are asked to find the rate of his petrol consumption in kilometers per liter. We are asked to find the rate of his petrol consumption in kilometers per liter. Okay. So I want to suggest a working method. Okay. When it comes to this question. So there is a triangle, which is a general triangle which we can use whenever we are dealing with rate questions. And I just want to take a moment and explain it. So here at the bottom, you are going to have a rate. Okay. Then here you have what I call your first quantity, which I will call quantity A. And then here you have your second quantity, which I will call quantity B. Okay. So if you want to calculate the rate of something, you take quantity A, which is usually, guys, I'll tell you this, when you have let's say kilometers per hour, which is obviously a rate, from this side of the division line you will have quantity A. On this side of the division line you are going to have quantity B. Okay, all right, I hope we are together. So that would mean that kilometers is what we refer to as distance. It's our first quantity, it's quantity A. That would mean that if we are talking about the rate of kilometers per hour, which is speed, it is basically made up of distance, which is quantity A. So quantity A would be my distance. Quantity B would be hours, which is represented by quantity B, which is hours means time. So that means time belongs here. And then the rate in and of itself, which is speed, kilometers per hour, that belongs there. So that's where we have DST. So for distance, speed, and time, all right, this DST is commonly known, and using this triangle is something learners commonly know. But what about when we are dealing with rate that does not involve distance, speed, and time? Okay, remember that when I unpacked this, I said here in this part we have rate. Here at the top we have quantity A, and here at the bottom we have quantity B. So for instance, speed has the unit kilometers per hour, and what I'm saying is, in that rate, the first part represents quantity A. The second part represents quantity B. So what is the first part here? It is kilometers. And what is kilometers? It is distance. The second part, it is hour. What is hour? That represents time. So therefore, quantity A is here at the top always. Quantity B is here at the bottom right always. And then all of this kilometers per hour represents speed, which is our rate. So for instance, with DST, when we are talking about distance, speed, and time, we have this triangle to work with. And our formulas for each are very evident. If we want to calculate speed, we say distance divided by time. If we want to calculate time, we say distance divided by speed. If we want to calculate distance, we say speed multiplied by time. S and T are next to each other, so we think of multiplication horizontally. But if we want speed, as I said, we say distance divided by time. If we want time, we say distance divided by speed. Okay, so this triangle is helpful. But for other quantities, I repeat, other what? Quantities that have other units that are not distance, speed, and time, we can use this general triangle, which says what? The general triangle says quantity A at the top, quantity B at the bottom, our rate here on the left corner of the triangle, left bottom. Okay, so let's come here to this and read it so that we can assist ourselves in calculating the rate here. So the question says a car driver needs 18 liters of petrol to travel 252 kilometers. Okay, so 18 liters is a quantity to travel 252 kilometers. 252 kilometers is another quantity. These quantities have different units. Rate is the comparison between two quantities that have different units. So 18 liters, this is liters of petrol, is different from 252 kilometers. But in the comparison of these two quantities, we need to find the rate of the petrol consumption in kilometers per liter. So this is what I want to say. They want the rate in kilometers per liter. What does this suggest? The first quantity here, kilometers, is going to be my quantity A. The second quantity in my rate is going to be my quantity B. Okay, what is quantity A? This is distance, because kilometers represents distance. What is quantity B? Liters. Obviously, that is just the amount of petrol. Okay, that's a petrol amount. And then what is kilometers per liter? It is the rate of consumption. So what I'm going to do in my triangle, I know very well that for this triangle, rate obviously is down here. At the top, I have kilometers, which is my quantity A, distance, and then my amount of petrol is going to be here. What do they want me to calculate? Well, the question says find the rate of his petrol consumption in kilometers per liter. So let's go. I'm going to say a rate of consumption is equal to, this is what I want. So then I'm going to take the distance in kilometers and I'm going to divide it by the amount of petrol in liters. Simple as that. Then I go and actually identify the amount. The distance in kilometers is 252, and I'm going to divide that by 18 liters of petrol. That means 18. So what is the petrol consumption? You give me the answer. What is 252 divided by 18? What is 252 divided by 18? What is 252 divided by 18? So that I can then tell you in kilometers per liter, what is the rate of consumption? Okay, so I'm waiting for someone to give me the answer. Oh, you guys are waiting for me to give myself the answer. Okay, thank you, Oshin. 31.5. Okay, kilometers per liter. Guys, I hope we are understanding each other with these questions. Okay, I hope we are understanding each other. Okay. Lily, no. Question is, Lily, when did you join the live? And if you're saying no, at what point did you join the live? Did you join it halfway? Did you join it at the beginning when I was explaining? Oh, it's 14. Yeah, these people. Hi. Ocean. See, I'm trusting you too much. I think I'm going to have to bust out my own calculator. Okay, sure. I'm going to have to take out my own calculator and calculate mass. 14 kilometers per liter. Okay, thank you for that correction, because at least it's not a train smash. 14 kilometers per liter. Hopefully when people watch the video when it's been uploaded, they can actually take the time and pause and actually type in, right? Because I upload these videos on YouTube, guys. You can watch the live lessons again at your own time. Okay, so let's look at the next question. The question says, if the petrol price is 11 Rand 50 per liter at this stage, how much does the petrol for this trip cost? If the petrol price is 11 Rand 50 per liter at this stage, how much does the petrol for this trip cost? 11 Rand 50 per liter. Right. So this is very important. If we have 11 Rand 50 per liter, the reality that what this is, it is a rate. So now we have other quantities at work. Okay, because this is a typical rand per liter. So 11 rand 50 per liter. This is a rate. Okay, it is a rate. And guys, we know where the rate belongs. The rate belongs here. Then we need to then identify what is our first quantity. It's the amount. It's the price amount. That's quantity 1. How do you know quantity 1? It is the first quantity. Then quantity B is the liters that we have. Does that make sense? So what do they want? They want us to do what? If the petrol price is 11.50 per liter at this rate, how much does the petrol for this trip cost? Guys, the car driver needs 18 liters of petrol. Okay, 18 liters of petrol. So what we are wanting to know is how much does the petrol cost. So we want to know the price amount. Okay, what are we given? What are we given, guys? We are given 11.50 per liter. What is this? I told you that this is rate. Why do I know it's rate? It's because it is given as rands per liter. Rands per liter. This quantity is what we call our rate. A combination of the two quantities as a ratio, as a rate. So R rand per liter. As I said, the first quantity here, rand, belongs here at the top. Liter belongs here at the bottom. Rands, or the amount of money, the price is the quantity A. Liter is quantity B. And then the entire rate per liter, the entire rate, rand per liter, belongs here. This is something you need to identify all the time, guys. You know, what you are given, what is it? This is our rate. Where does it belong? Here. Then the R represents price, or the amount that we need to pay. So where does that belong? Since it's the first quantity, quantity A belongs here. Then L per liter. L is my quantity B. Where does it belong? It belongs right there. Okay. Then what do I want to calculate? The question says, if the petrol price is 11.50 per liter at this stage, how much does the petrol for this trip cost? We want the price, or the amount. So the price amount for the petrol is going to be equal to, now when we want what's at the top, what do? We take the rate, and what do we do with it, with the liters? We take the rate, we multiply horizontal next to each other. We take the rate, we multiply by the liters. So that means we are going to take 11.50 and multiply it with 18 liters, so that we can find out how much does the petrol for the trip cost. Remember, the trip is 252 kilometers, but we need 18 liters of petrol. So the question is, how much does the petrol for this trip cost? So we're going to say 11.50 times 18. Guys, what is 11.50 times 18? I think I need to get my own calculator. My fellow, what do you call, joinees in life. How many activities I would want? I don't know if it's because they're bored, because it's not pure math. Well, it's actually like grade 8. Okay, 11.50. We multiply by 18. We get 207. So the amount of money that we need to pay for the petrol is 207 rand. That's the price. For the petrol, it's 207. Okay. Okay, let's move on to the next question. Next question says, if the petrol price is reduced in the ratio 8:7, how much would the petrol for the same trip cost now? Let's repeat that question again. If the petrol price is reduced, okay, in the ratio 8:7, okay, how much would the petrol for the same trip cost now? So thankfully enough, I've found out what the petrol for the trip costs. It's 207 rand. That's the petrol price for the trip, for the entire trip. Okay, it's 207 rand. That's the petrol price for the entire trip. Now, if the petrol price is 11.50, sorry, if the petrol price is reduced in the ratio, so what are we talking about here? If the petrol price is reduced in the ratio, now we are talking about the decrease of a quantity in a ratio. Okay, the word reduce just means we are decreasing a quantity in a particular ratio. So if the petrol price is reduced in the ratio 8:7, how much would the petrol for the same trip cost now? So we are going to say the new quantity is equal to the given or original quantity which we have, and we multiply that by what? Now, since the question says reduce 207 in the ratio 8:7, we are going to have the small number in our ratio at the top over the big number of the ratio at the bottom. Small number of ratio at the top, big number of ratio at the bottom. Guys, this is what we do always whenever we're calculating a new quantity, when a specific quantity has been reduced in a specific ratio. So what is the quantity or the amount? It's 207. We are going to multiply that amount by the small number in the ratio. What is the smallest number in the ratio? Well, it is 7. What is the big number in the ratio? It is 8. Okay, so we say 207 times 7 over 8. What is the question saying? If the petrol price is reduced in the ratio 8:7, how much would the petrol for the same trip cost now? So the current petrol price is 207 rand for the whole entire trip. If we reduce this in the ratio 8:7, what is going to be the new quantity or the new petrol price? So we take the original quantity, which is 207 rand, which is the original petrol price. We multiply it by the ratio or the rational number, rational fraction, where the smallest number in your ratio will be in the numerator, because we are told to reduce. So if we're told to reduce, the small number must be at the top, whereas the big number in the ratio must be at the bottom. Had we been told to increase or enlarge the amount or the price, then we basically have the big number at the top and the small number at the bottom from our ratio. So because we are told to reduce, small number over big, then all we do is you grab your calculator and you say 207, you multiply it by fraction, very nice, 7 over 8, makes life very easy. You get 1449 over 8. If you want to express that fraction as a decimal, you press SD. Okay, then you get 181 rand 13 cents. Okay, there's 125 in 81,125. Typically we are always asked to round off our answers to 2 decimal places. So because we have two numbers after the comma. The third number, we ask, if this number is 5 or more, then it means we add 1 to 12. But if this number was 4 or less, we would leave 12 as it is. So because 5 here is a number that is 5 or more, that means we add 1 to 12, so we get 181,13. What do you notice, guys? You see, the price was 207 Rand. Now the price has really been reduced. It's been made smaller when we actually divided, or we reduce it using the ratio 8:7. 7 small number at the top, 8 big number at the bottom. Then we are able to calculate the reduced amount, which is 181 Rand 13 cents. Okay, that was not too difficult, was it? So when we are ever asked to reduce a quantity using a given ratio, that's what we do. You take the new quantity which you have been, to calculate the new quantity that has been reduced, you take the given or the original quantity, which is what we had there, 207 Rand. You multiply it by small number of ratio over big number of ratio. There it is, 207 times 7 over 8. Put this in your calculator, you get the answer, no problem. The last question. How many liters of petrol will he need to travel 280 kilometers? How many liters of petrol will he need to travel 280 kilometers? So let's go back to our rate triangle. Okay, remember, what do we have here? How many liters of petrol will he need to travel 280 kilometers? Okay. Now, remember, we have rate here. How many liters? So we are still dealing with liters of petrol with distance. So that means distance is here. We remember most liters of petrol will be here. Okay. How many liters of petrol will he need to travel 280 kilometers? So we have a distance of 280 kilometers. What is the rate again that we had been exposed to? We were told that okay, so the rate of his petrol consumption. What did we calculate the rate of his petrol consumption to be? So we need to go back to 3.3.1. What was the rate of his petrol consumption? Because we need that 14 kilometers per liter. That was the rate of his petrol consumption. So we need that rate. That rate was 14 kilometers per liter. How many liters of petrol will he need to travel 280 kilometers? So that means to find this, L we don't know, D is 280 kilometers, and then the rate is actually 14 kilometers per liter. So now let us go and find L. To find L, we are going to say distance over rate. So L liters, which is liters of petrol, is equal to 280 kilometers divided by 14 kilometers per liter. Okay. That should be quite nice. Okay. Yeah, that is 20, right? If I'm not mistaken, 20 liters. How many liters of petrol will he need? He will need 20 liters of petrol. Okay. He will need 20 liters of petrol. Okay. Yeah, this is for the grade 8s and 9s, guys. This is for grade 8s and 9s. we've been doing a lot of grade 10 and stuff, but now we need to give these boys and girls some attention as well. Okay, that was nice. Okay, ratio and rate. Okay, let's look for some other types of questions here. Let's see. Look, write the following ratios in their simplest form. Okay, write the following ratios in their simplest form. So let's check out. So here's another ratio, 12:32. We need to write 12:32 in simplest form. So what do we do to write 12:32 in simplest form? So we have two quantities, they are of the same type. So what do we first do? We find the highest common factor between 12 and 32. What is the biggest number that goes into 12 and 32 without leaving a remainder? Okay, so if we look at 12 and we look at 32, okay, we could quickly find the highest common factor using our famous ladder method, Okay, so let's quickly look for the prime, the prime numbers that go into 12. Okay, the smallest. All right, so prime numbers, guys, are numbers like 2, 3, 5, 7. Prime numbers are numbers that have only two factors, one and itself. So for instance, the number 2 has two factors, 1 and 2. The number 3 has only two factors, 1 and 3. Okay, prime numbers are like that. They have only two factors, the number 1 and the number itself. There are no other numbers that are factors of that particular number. So what is the smallest prime number that goes into 12? We have 2. How many times does 2 go into 12? 6 times. What is the smallest prime number that goes into 6? It is 2. How many times does 2 go into 6? 3 times. What is the smallest prime number that goes into 3? It's 3. How many times does it go into 3? Once. So once we get to 1, we stop. Okay. Then we can write 12 as 2 times 2 times 3. How many 2's? I have 2 2's. How many 3's? Just 1 3. Then we repeat that with 32. Smallest prime number that goes into 32 is 2. How many times? 16. Smallest prime number that goes into 16 is 2. How many times? 8 times. Smallest prime number that goes into 8 is 2. How many times? 4 times. Smallest prime that goes into 4 is 2. How many times? 2. And how smallest prime that goes into 2 is 2. How many times? Once. We stop right there. So that means the number 32 is going to be 2 times 2 times 2 times 2 times 2. How many 2's do we have? 5 of them. Okay. So when written down, it means 12 is 2 squared times 3, whereas 32 is 2 to the power 5. 2 to the power 5. So what is the highest common factor between 12 and 32? Guys, when you identify the highest common factor, we are looking for the common base with the lowest exponent. Common base with the lowest exponent. Common base for the existing numbers. Okay, so if for the existing numbers the number is not common, we don't identify it. So for instance, what's between 2 squared and 2 to the power 5? Which one is 2 common? Yes, it is. Which one has the base with the lowest exponent? It is 2 squared. What about base 3? Is it common? No, it isn't. So it means we are not going to include it as part of the highest common factor. So that means the highest common factor here is 4. Okay, so I know the highest common factor between 12 and 32 is 4. So what I then do is I take that highest common factor, which is 4, I divide both quantities by 4. When I have so done, 4 goes into 12 how many times? 3 times. 4 goes into 32 how many times? 8 times. So the simplified ratio is 3:8. That's how I simplify. You identify the highest common factor, divide both quantities by the HCF, and then 3, you arrive at the simplified ratio, just like that. Okay, question number 2. Let's see if we can simplify this here. Now, remember, a ratio can be simplified if both your quantities, 1, are of the same unit. So currently here we have rands, whereas this side we have cents. We can't have rands and cents, so we need to convert these rands into cents. So how do we convert rands so that this is all in cents? So 2 rand 25 cents can be written as 225 cents. Then we can say 225 cents is 235 cents. So the quantities currently are having the same unit. This is where we have to begin. So 2 rand 25 cents and 35 cents are now written as quantities that exhibit the same unit. And 2 rand 25 is now a whole number instead of a decimal, because you cannot simplify a ratio if the two numbers, one is a decimal and the other is a whole number. You have to have them as best as you can, both whole numbers. Okay. So now we have two whole numbers. We converted 2 rand 25 so that it can be represented in cents. So the conversion is the first step. Okay. So there are times when you have to first convert one of the two units so that we have the same units, because at the beginning we didn't. Okay. And what are the conditions, or what are the requirements to be able to simplify a ratio? 1, whole numbers. Okay. No decimals. So that's why, for instance, 2 rand 25, we could not tolerate this. We needed to convert 2 rand 25 into a whole number. So if you convert rands into cents in its entirety, then 2 rand 25 is actually 225 cents. Okay. 35 is already having a whole number. Okay, so now we have whole numbers on either side. That's the first condition. Requirement is that we need to have whole numbers. 2, that's the first requirement. The second requirement, units must be the same. Because remember, what is a ratio? Ratio is the comparison between two quantities, but they must be of the same type. They must have the same unit. Okay, so then now that we have these at the same unit and we have whole numbers, now we can, step number 2, the requirements are met. So step 2 is to then find the highest common factor between what? 225 and 35. Can we find it? Yes, we can find the highest common factor between 225 and 35. Right? Okay, so if we use our famous letter method to find the highest common factor, Okay, and let's use our famous ladder method to find the highest common factor. Okay, so we are going to identify the prime number, the smallest prime number that goes into these numbers. We are going to identify the smallest prime number that goes into these numbers. So here, 225, 3 is the smallest prime number that goes into 225. Okay, the lives start at 4. Sorry, the lives start at 4:30 in the morning. Okay, the person was asking. So 3 goes into 225 how many times? 75 times. Okay, then you identify what is the smallest prime number that goes into 75. It is 3. How many times does it go into 75? It goes into 75 25 times. Smallest prime number that goes into 25 is 5. How many times does it go into 25? 5 times. Smallest prime number that goes into 5 is 5. How many times does it go into 5? Once. Then we go to 35, we do the same thing. Smallest prime number that goes into 35 is 5. How many times? 7. Smallest prime number that goes into 7 is 7. How many times? Once. Okay? Yeah. So then for 225, you can write down the products. Okay? How many 3's do you have? 3 times 3. How many 5? 5 times 5. With 35, how many 5's? We don't have any 3's. We have 5 times 7. So if you write down how many 3's, we have 2 3's, we have 2 5's. And then with 35, we have 5 times 7. There's no 3. Remember, with the highest common factor, we are going to write down the product of the common base with the lowest exponent. I repeat again, we are going to write down the product of the common base with the lowest exponent. So if you look at base 3, okay, it is there for 225. Is base 3 there for 35? No. So that means 3 is not a common base. So we move on to the next base, base 5. Is base 5 a common base? Yes. Base 5 is here and base 5 is there. Then we ask ourselves, what is the common base between these two that has the lowest exponent? It is 5. 5 has the lowest exponent. Then we go to base 7. Is base 7 common? No, it isn't. So therefore it means our highest common factor between 225 and 35 is 5. It's as simple as that. Common base with the lowest exponent, the product of the common bases with the lowest exponent. So we are going to come here, 225 and 35. What is the highest common factor? Well, the highest common factor is 5. We've identified the highest common factor. Step 3, we divide each quantity by the highest common factor. We divide each quantity by the highest common factor. So we're going to divide by 5, divide by 5. So what is 225 divided by 5? What do we get? We get an answer of 45 is 2. We don't need the units to be there. 35 divided by 5, it is 7. This is a simplified ratio. When the ratio has different units and one is a decimal and the other is a whole number. So as I repeated and as I say again, whenever we have a ratio that we need to simplify, one is in decimal, the other one is a whole number, the requirements are that 1, the whole numbers need to be represented for both ratios. We can't have a decimal in our ratio. So that's why we converted 2 Rand 25 cents to 225 cents. Converted rands to cents. 35 cents is fine because it is a whole number. Now we have both whole numbers and 2 units must be the same. Now we have 225 cents, we have 35 cents. The units are the same and they are whole numbers as well. Step number 2, find the highest common factor between those two whole numbers, which we did here using the ladder method. We found the highest common factor, it is 5. Okay, and then last but not least, we take that highest common factor, divide both quantities by it, so that we can get the simplest ratio that is possible. And that basically wraps up that. Okay. Okay, let's look at another one. Okay, 4/7 is to 5/21. Okay, so here what do we have to do? We need to write the following ratio in its simplest form. Okay, so what we do with this particular question, if we were to write the ratio in its simplest form, we will need to first look at the denominator. So when we look at the denominator, we find that the denominators are not the same. Well, then our first mission is to make the denominators the same. How? We find what we call the LCD, lowest common denominator. So between 7 and 12, guys, what is the lowest common denominator between 7 and 12? Or in other words, what's the lowest common multiple between 7 and 21? Not 7 and 12, 7 and 21. So if I count in 7s, 7, 14, 21. If I count in 21s, 21. Okay, so the lowest common multiple between 7 and 21 is 21. Okay, 2, write the fraction having that LCD. So now I need to make sure that both of these fractions have that LCD. So what do you see here, guys? The 21. What do we need to do to 7 to get 21? We need to multiply it by 3. But remember, what we do at the top, we do at the bottom, we do at the top. So write the fractions having LCD. We call these fractions equivalent fractions. We call these fractions equivalent fractions. The minute we change a particular fraction so that it actually has the property of the denominator that we're wanting to align it to, then it means we are changing 4/7 to its equivalent fraction, where the denominator is 21. And how did we identify 21 as the LCD? We basically looked at the multiples of 7 and 21, and we identified the lowest common multiple between 7 and 21. Then we looked at the denominator and we were like, what do we need to do to 7 to get 21? We multiply by 3. So what we do at the bottom, we do at the top. We now have 12/21 is to 5/21. Okay. Now the minute the denominators are the same, we can then relate the numerators to each other. Okay. The minute the denominators are the same, we can then relate the what? The numerators to each what? To each other. So then my simplified ratio for 4/7 is to 5/21 is actually 12/5. That's as simple and as straightforward as that answer is. Okay, 12/5 is my answer. Okay, so that's how we deal with simplifying a ratio that has denominators that are not the same. We look at the LCD for those given denominators of that particular what fraction. So between 7 and 21, we could see that the LCD between 7 and 21 is 21. Then we multiplied the first fraction by 3 in the denominator. We did likewise in the numerator, so that we can form the two fractions using the equivalent fraction. We form the equivalent fraction of 4 over 7, which is 12 over 21. Then after that, we ignore the denominators and we write the numerators as basically your ratios that we should have. Okay. Yeah. So I hope this is absolutely coming together, because it ought to. It really ought to. Ratio and rate are really nice concepts, if you want to call it that. Nice concepts. Okay. Yeah, well, I think I'm going to end the live here. Thank you so much, guys. It was great that you could join when you did. Yeah, have a good day, and yeah.